guys, today is the start of a new chapter, and this chapter covers exponent properties as well as scientific notation eventually. And today we're going to start by just going over some exponent basics, some stuff that you guys have probably learned about before, maybe some new words. I know there's going to be one new rule, and then by the end of today we're going to be solving equations with exponents in them. So we'll start off by just filling out this chart. I hope you can excuse my setup here. I was having a hard time with my printer, so I'm trying to improvise. So hopefully you guys can follow along with my crooked lines. Mrs. Ramson will be having a heart attack over the lack of use of a ruler here. So let's not tell her. So for this chart, I'm going to be filling out exponential form, base, power, expanded form, and standard form. And the idea of this table is to just refamiliarize yourself with these words and kind of play around with what exponents mean. So exponential form is when we have something like this. We have a base and a power. So we kind of just did three vocab words in one. Exponential form is when it's not simplified. It's just written out using a base, a big number, and a power, the little exponent up top, and it's not simplified. The base is just going to be the big number. I remember that. Base, big, both start with B. So the base in this example here is going to be 4, and the power is going to be 3. Another word for power is exponent. It's the little number up top. Expanded form is a way that we're just going to write it out showing it in multiplication. So for example, 4 to the third. Don't make the mistake of doing 4 times 3. That's not what that means, and kids do it every year. It's 4 times 4 times 4. So 4 times itself 3 times. And we write that out like this, 4 times 4 times 4. And then standard form is just going to be like a normal number, like you guys see all the time. So examples of that would be 109, 1, just normal numbers. So we actually have to multiply out the exponential form and the expanded form to get the standard form. So standard form here, we would do 4 times 4 is 16, times 4 again is going to be 64. So that's how this table works, and we'll just go through the rest of it. So the negative numbers we're going to pay close attention to, the negative bases, I should say. So for this one, I have a base of -2. It's in a parenthesis, which is really important because that means that the whole -2 is being multiplied 5 times. So my base here is -2. The power is the little guy, that's going to be 5. And expanded form, I'm going to write it out using multiplication. So I have -2 times -2 times -2 times -2, and one more. There we go. And the first thing I'm going to be careful with is my sign here. So I am multiplying by a negative 5 times. So if I do a negative times a negative, that's a positive. Times a negative is a negative. Times a negative again is a positive. Times another negative is going to leave me with a negative answer. So when I multiply, it's just a little trick moving forward. And you can always go back to expanded form to figure it out. But when you're multiplying with a negative base and it's an odd exponent, you're going to be left with a negative answer. If you're multiplying a negative base by an even exponent, so if we had -2 to the power of 4, for example, we would have ended up with a positive answer. So for this one, now I'm going to go back and do the actual number. And the actual number here is going to be 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I have -32 as my standard form there. Next, I have a fraction. We're not going to freak out. We're just going to take it step by step. For the base, I just have 3/4. My power is a 2. Expanded form, see, this is easy. 3/4 times 3/4 for expanded form. And then standard form, I'm just going to multiply my numerators by my denominators. So 3 times 3 is 9. 4 times 4 is 16. And we are done. This next one, I want you guys to kind of compare it to this one as I'm talking. So the two negatives. I have a -3. That whole -3 is not my base though. And this is super important to pay close attention to. That 4 is not touching the negative. It is not touching it at all. I have a 3 in between it. That 4 is only applied to the 3 here. So my base is actually just 3. I'm going to write it like that. And the power here is going to be 4. And that negative, I'm going to kind of just put it off to the side and I'm going to remember it later because my answer is always going to be negative when I have something written like this. So I'm going to write it when I do it in expanded form. I'm actually just going to hold the place with like a -1. You could put just a negative there if you wanted to. That's completely fine. And then I'm going to write out my base and my power. So I have times 3. Times 3, I'm just writing it as a positive number. And it's 4 times that I'm writing it. So I know my answer is going to be negative because of that. Put my negative there. 3 times 3 is 9. Times 3 is 27. Times 3 again is going to be 81. So I have negative 81. So those top 4 rows kind of show you how you can break it down going from exponential form. The bottom 3 are asking you to kind of work backwards to get back to exponential form and use what's given to you to figure out the rest. So this next row gives me a base of 10 and a standard form of 100. So I need to look back and say, well, what power would make 10 100? 10 times itself, how many times gives me 100? Well, I know that 10 squared is 100, meaning 10 times 10. And then the exponential form is the easy part. I'm just going to write the base and the power. The big number is 10, the base, and the power is going to be 2. This next one gives me a power in a standard form now. So I know something squared, something times itself, gives me 9. Well, we know that's 3. So my base is 3, my power is 2. That's easy to write out in expanded form. Oop, 3 times 2. I said 2, wrote 2. It's 3 times 3 gives me 9. And then when I come back here, the easy part, exponential form, 3 squared. This next one, again, gives me a power in a standard form. This one's a little tricky, though. What number times itself 7 times gives me 1? And every year, most kids try to think about like a fraction or a really little decimal. But what is actually happening here? 1 times itself 7 times gives me 1. So it actually wouldn't matter what that power was. It could be 8, 9, 10, 100, doesn't matter. 1 times itself 7 times gives me 1. So I'd write this out 7 times. 2, 3. 1 more. There we go. And then exponential form, 1 to the 7th. And last but not least, we give you a variable as the base here, and we give you the power. So this one, I'm just going to write x to the 5th. We don't know what x is, so we need to show this one algebraically. You can say x times x times x 5 times. That's how we would write it out expanded. And for standard form, again, we don't know what x equals, so there's no other way to write it other than just using the variable with the exponent. And you would be done. So hopefully that kind of brings that back for you. You guys have used all of these words before in years prior to right now, but we just like to kind of go over that again for you. So next up on our list says use the patterns of the power, use the pattern of the power of 10 to remember these 2 facts. And we have not filled that out yet. I have this set up over on the wall for you. That's kind of off to the left if you're following along with notes. I'm just going to come over here. So patterns of the power of 10. I have 10 to the 4th down to 10 to the -4th listed out for you. And I like to start right at 10 to the 1st. That one's kind of easy to start with. So 10 to the 1st is going to give me just 10. 10 squared gives me 100. 10 cubed, 1,000. And 10 to the 4th power is going to be 10,000. Now, a way to remember this that I like to point out, when I have a 10 to the power of 4, notice how there's 4 zeros. 10 to the power of 3, 3 zeros. 2, 2 zeros. 1, 1 zero. So that's a good way to check it for yourself. And as I'm going down, I'm subtracting the exponent, right, in my left-hand column, my 10s. Over here, what's happening is I'm dividing by 10 as I go down. Dividing by 10, dividing by 10, because you guys have never talked about yet, this is that one new rule I told you we were going to find out. You've never talked about something to a 0 power. I think we might have had one in a review packet earlier in the year, and I put it up on the board, but we didn't talk about why. So we're still not going to talk about why today, but I'll kind of show you how you can use this pattern to figure it out. If I'm dividing by 10, here I get 10, and divide by 10 again. So if I'm following this pattern, 10 divided by 10 is 1. So that's going to be important. And I'm going to keep going. 10 divided, or 1 divided by 10 is 1/10. 1 over 100, and now I'm just kind of using a fraction. So this is going to be important as we go on. In future rules that we learn, we're going to talk about what negative exponents mean again. This is also new for you today, but we are just figuring that out by using the division of 10 rule. So that is what we have, and then down below we can fill in those rules. It says use the pattern of the powers of 10 to remember these two rules. Well, the rules are any number to the 0 power is going to be 1. Any number to the 0 power is 1. And any number to the first power is going to be itself. So you guys knew that one already, but you didn't know the 0 power. And I'm out of space here. Write it over here. Itself. So for 0 power, I have these two examples on the outsides. 17 to the power of 0 is 1. 6,389,000 to the power of 0 is 1. X to the power of 0 is 1. Anything to the power of 0 is always 1. If I have x, y, z to the power of 0, it's 1. When I have something to the power of 1, it's itself. So 8 to the power of 1 is 8.